Hello, good morning students. This is Narendra Jain, Director Manthan Career Institute, Director Parshv International Senior Secondary School. Students, we are going in the 12th organic chemistries and the main topic of the today is the stability of the various reaction intermediate. In the last video, we have discussed the types of the reaction intermediate. Today, we are going to discuss the stability of the various reaction intermediates. See, we have got the three types of the main reaction intermediate. The first is the free radical, second is the carbonium ion, and the third one is the carbanaions. Along with that, certain intermediates are carbene, benzene, and nitrene. If we are focusing on the 12th, then these three are main: free radicals, carbonium ion, and carbanaion. Overall, for the JEE and the NEET, we have to discuss the 6 types, that is remaining 3 types also: carbene, benzene, and nitrene. First, we are discussing the 3 types of the intermediates and their stabilities. So, the first is the heading is the stability of the reaction intermediate. We are focusing on the free radicals. We have discussed earlier, we have got the 3 types of the free radical: primary free radical, secondary free radical, and the tertiary free radical. See, CH3CH2 dot, CH3CH3 dot, CH3C CH3CH3 dot. We have got the 3 types of the free radicals. Remember this point, I have told in the last video also that these are electron deficient species. Free radicals are electron deficient. No matter they are, we have got the odd electrons, but even then the free radicals are electron deficient species. Now see, in the earlier classes, you have already discussed the I effect. I means inductive effect. We have got the 2 types of the groups which shows the inductive effect. The first one is the plus I effect and the second one is the minus I effect. If a group shows plus I, it means it will develop positive charge. What is the I effect? Shifting of the sigma electron. If a group shows plus I, it means it will develop positive charge on its own. So, if it is going to develop the positive charge on its own, then it will donate its electron. If any species want positive charge on its own, then it is possible when it donates its electron. So, it is called as the electron donating group. All plus I effect showing groups are electron donating group. Example is the best is the all alkyl group: methyl, ethyl, propyl. All of them shows plus I effect. And minus I effect, if a group shows minus I effect, it means it will have the negative charge. And how it will attract the electron towards itself? So, such groups are called as the electron withdrawing group. We have got the halogens like X, fluoride, chloride, bromide, iodide, OH group, NO2, cyano, etc. These are the important minus I effect showing group. One is the electron donating, second is the electron withdrawing. Now, my question is that out of these 3 free radical, which is maximum stable? Remember students, I have written this thing in the bracket, in the box. This is, in the Hindi I can say it's a Brahmastra. It is never wrong. Stability of the reaction intermediate. Whatever and whichever is the reaction intermediate, its stability of the reaction intermediate is proportional to 1 upon charge density. I have not written positive or negative. I have written only is proportional to 1 upon charge density or electron deficiency. Means stability of the reaction intermediate is inversely proportional to charge density or inversely proportional to electron deficiency. Now see, we have got the 3 types of the free radical: primary free radical, secondary free radical, and the tertiary free radical. In the case of the primary free radical, one methyl is there. This methyl shows plus I effect, so it will give its electron or shift its sigma electron to this CH2. In the case of the secondary free radical, I have got the 2 methyl groups. These are the 2 methyl groups. What they will do, again the nature is the same. They will shift their electron to the free radical carbon. Now see, in the case of the tertiary, we have got the 3 plus I. They will again shift their electron to the free radical carbon. In these three conditions, all of them are shifting their electron. Now see, since 3 plus I will shift their electron maximum to the free radical carbon. Remember, they are only shifting, they are not transferring. That's why they will decrease the electron deficiency. Here also they are going to decrease the electron deficiency. Here also they are going to decrease the electron deficiency, and here also they are going to decrease the electron deficiency. Now see, tertiary free radical has the least electron deficiency. Why? Because 3 plus I are there, they are all giving their electron to the central carbon. So the central carbon, the free radical carbon, has got the least electron deficiency in the tertiary free radical. What I have written, see, stability of the reaction intermediate proportional to 1 upon electron deficiency. That is, where the electron deficiency is least, that will be maximum stable. So in this case, tertiary free radical has got least electron density, so it is max stable. Maximum stable is tertiary free radical, and the order of the stability of the free radical is tertiary is more than secondary and secondary is more than primary. This is the order of the stability. Okay, so this is the explanation of the free radical. Now if we move on the carbonium ions, see, again we have got the three types of the carbonium ion: the primary carbonium ion, the secondary carbonium ion, and the tertiary. This is primary, secondary and tertiary. Are you been able to see methyl is 1, methyls are 2 and methyls are 3. Again they will show the plus I. So here I have written 1 plus I group, here I have written 2 plus I group, here I have written 3 plus I group. See, although we have got the positive charge, but due to the plus I, the positive charge density will decrease. Why decrease? Because they have got the deficiency and they are supplying. They are also supplying. So the least positive charge density will be in this case. Why? Because 3 plus I groups are there, so they have the least positive charge density. And what I have written here, stability of the reaction intermediate is proportional to 1 upon charge density. It means which is maximum stable, tertiary is more than secondary and secondary is more than primary. This is the general concept of the stability. So the tertiary free radicals are, tertiary carbonium ions are more stable as compared to secondary, and secondary are more stable as compared to primary carbonium ion. Remember students, in the stability of the carbonium ion, we have to keep in mind the shift. The methyl shift is there, hydride shift is there, phenyl shift is there for the stability of the carbonium ion. It will be explained in the another video, that is stability of the carbonium ion. Here we are overviewing the general stability order. For the free radicals, tertiary is more than secondary is more than primary. Again for the cations, carbonium ions, tertiary is more than secondary is more than the primary carbonium ion. Now if we go for the stability of the carbanions, it is very clear. Again the carbanions are of three types: primary carbanion, secondary carbanion and the tertiary carbanion. Now see, carbanions have got the negative charge and the negative charge. Here all carbanions have the negative charge. Getting this point? See, this is methyl, one methyl group. It will donate its electron to the carbon which is already negatively charged. So what it will do? It will shift its electron and it will increase the negative charge density. Here two methyl groups are there. Again they will increase the negative charge density. Here three methyl groups are there. Again they will increase the negative charge density. But in the case of the tertiary carbanion, maximum negative charge density will be there. It's very clear. Why? Because 3 plus I groups are there. They will donate their electrons to the negatively charged carbon. Already it has got the negative charge, and further you are donating the electron to the negative charged carbon. The picture is clear. Maximum negative charge density will be on the tertiary carbanion. So therefore order of stability of the carbanion, what I have written here, stability of the reaction intermediate is proportional to 1 upon charge density or electron deficiency. So see, the order of stability is primary is more stable than secondary and secondary is more stable than tertiary carbanion. So in the case of the carbanion, primary is more stable, while in the case of the free radical as well as in the case of the carbonium ion, tertiary is more stable. So this is the very clear conceptual picture of the primary free radicals, for the free radicals, for the carbanions and for the carbonium ion. This is the overview, and it is very important because in the next video what we will discuss the preparation of the haloalkanes. We are going for the haloalkane preparation. So in the case of the preparation of the haloalkane, in order to explain, there are certain topics we have to explain these things, that the stability of the free radical, the stability of the carbonium ion, the stability of the carbanaion. Now see this, students, in the cloud I have written a certain line. This is again a Brahmastra. No exception to these lines. Nobody can create any exception. What I have written, the rate of reaction, either we say rate of the reaction or we say reactivity of the reactant, one and the same thing, I will explain, or we say stability of the product, or we say formation of the product. All these four concepts means same, the presentation is different. Now see, to explain this, we take an example. Consider a reaction A plus B forming an intermediate AB with the positive charge, and the final product is the C. A reaction A and B are reacting together to form an intermediate AB plus, and the final product is the C. See, I have written these reactions in the three ways: AB plus, and it is C. Final product is always C. A plus B, they are reacting, AB plus, the final product is the C. But the point is that product is the same, nature of the product is same. Point is that here the intermediate is the primary intermediate, here it is secondary intermediate, here it is tertiary intermediate. Now the question arises, where the C will form first? Formation of the product. Out of these three reactions, in which case the C will form first? Or we can say where the reaction is fastest, but obviously the reaction which is fastest is going to form the C earliest. So rate of the reaction, but obviously it is clear, if we are searching for the fastest reaction, it means we are searching that out of these three reactants which will react fast, that is the reactivity of the reactant. Either we say the rate of the reaction or the reactivity of the reactant, or we say the formation of the product, and that product will form earliest, which is maximum stable. So these four lines are connected together: rate of reaction, reactivity of the reactant, stability of the product, or formation of the product. All these four lines are relevant. Now see, if we want to find the answer of these four lines, don't see reactant, don't see product, see the intermediates. First of all, you should find which types of intermediate is there. Here we have got the positive intermediate. Okay. Now search that out of these three, which is maximum stable. Sir, we have discussed earlier, tertiary is maximum stable. So see, when both are reacting in these three reactions, all of them going to form the reaction intermediate. And keep in mind, no reaction intermediate is permanent stable, because if it is permanent stable, then it will not form the product. I can explain this by taking a very simple example. 3 students are there in the class, they are scoring 1 marks, 2 marks and the 3 marks in their examination out of 10. All of them are failed, all of them are weaker students. But what we have to do, if we have to search out of these three, which is the cleverest one, which is the smartest one, which is the intelligent student. So out of these three, this is the intelligent. Same here, all these intermediates are unstable. Remember this point, all intermediates are unstable. What you have to search out of the various types of the intermediate, which is comparatively more stable. See, so in this case, primary, secondary and tertiary, all of them are unstable. But we know out of the primary positive, secondary positive and tertiary positive, what I have written, tertiary is maximum stable. So in this case, it is maximum stable. What I have written, see here, rate of reaction or the reactivity of the reactant or the stability of the product or the formation of the product is directly proportional to stability of the reaction intermediate. What you have to see, you have to focus on the reaction intermediate, search out of these three which is maximum stable. In the case of the positive, it is maximum stable. More the stability of the reaction intermediate, more is the rate of reaction. So out of these three, it will be the fastest which is going to take part in the reaction. Why? This is the concept, because we all know that these three know that we are going to form the intermediate and all of intermediate are unstable, but comparatively it is more stable. So it will take part in the reaction first. So this product will form first. So what is the answer? The rate of the reaction or the reactivity of the reactant or the stability of the product or the formation of the product is directly proportional to the stability of the reaction intermediate. This is the Brahmastra, having no exception. If you want to solve any of the questions belonging to advanced, IIT mains, NEET, 12th, 11th, for this relationship concept, this is the finest way. By keeping in mind these two clouds, this is the one cloud and this is the second cloud, you can solve any of the question of the IIT. Okay, so this is the overview of the stability of the free radical, carbonium ion and the carbanaions. Next we will discuss the stability of the carbene, nitrene and the benzene.